99.5% is our duty factor. Okay? So that means they're listening 99.8 through 99.5% of the time. Okay? The duty factor on a continuous wave transducer, our duty factor is going to be 100% because it's always working, right? It's always transmitting. So our duty factor is 1 or 100%. Okay? So duty factor, if you just record it in a number, it should be, in diagnostic ultrasound, between 0 and 1. But if you convert it into a fraction, then it's going to be between 1 and 100%. Okay? So again, duty factor is also inversely related to the depth. So I always try to remember these together. PRF and duty factor always go in the same way. Right? If I'm not sending out pulses as frequently, then the machine's not working as often. Okay? So at shallow depths, our duty factor is high. See right here, at shallow depth, our duty factor is high because it's able to send out, it's able to transmit more pulses. Okay? When we're deep, our duty factor is low because it's not, the machine's not working as hard. It's not transmitting as many pulses. All right? Yes, ma'am. Coming to it. So next slide. All right? So if we want to determine our duty factor right here, duty factor, like I said, is the pulse duration divided by the pulse repetition period. Okay? We're just taking that percentage of what percentage of the pulse duration is of the pulse repetition period. Okay? So how we determine that number is pulse duration divided by pulse repetition period. To get our percentage, we're going to multiply that by 100, right? Mm-hmm. I do have homework, guys. I mean, not homework, it's not technically homework. This is a worksheet for you guys to work on, so you can kind of understand I don't want to say the math, so you can understand the relationships, so you can understand the relationships. Because I'm not going to sit up here and say I'm just going to have a whole bunch of math on the exam. I don't plan on doing that. I want you guys to know the facts. I want you guys to, most importantly, know the relationships between these parameters, these pulse parameters, these acoustic parameters. Okay, I want you to know the relationships more importantly. All right. So that's our duty factor. If we want it in percentage, then we have to multiply that by 100. If we don't multiply by 100, we're just gonna get a number, right? It's okay to label it as that, but you never know how I'm gonna ask a question. I may ask you a percentage. I may just ask you what the duty factor is.
If you ask
without one?
Like nothing. Well, I think right now that was an example with the 1. So can you give an example with another number?
See what I got. Okay. All right. So let's say our PRP. Y'all see this right here? Everybody registered for TSRT, right? Huh? Didn't y'all register all in one day?
Yeah.
Okay. Okay. So our formula is, and you guys may need to pull your calculators out so we can get this math done a little quicker. Act Siri or something.
Sweet.
Huh? Yeah, act Siri for me. Alright. So let's say our PRP is 50 microseconds, right? So that's remember PRP is determined in time. Okay? Alright? And let's say our pulse duration is also in time. Let's say that's 5 microseconds. Guys, the PRP is always going to be longer than the pulse duration, right? It's always going to be longer because we're listening 99.8% of the time. Okay? The machine's only working 0.2%. It's only transmitting 0.2% of the time in diagnostic ultrasound. Alright, so pulse duration, 5 divided by 50. What we got there? 0.1. Alright, so that's going to be our duty factor right there. Multiply that number by 100. What is that?
10.
10. So that means our duty factor is going to be 10%. 10%. Okay. Myra, was that clear? That clear? Jasmine, you good? Yes, ma'am.
The PRP 50 microseconds per second
PRP, remember, it's the beginning of one pulse to the beginning of the next pulse. That's the time it takes for that to happen. The time it takes for that. That's why it's in microseconds. That's why it's in microseconds. Guys, I'm going to finish this chapter. So bear with me. Bear with me. We started late anyway. All right, but we good on duty factor. Don't just rush me, guys. Y'all want to go? I'm gonna let y'all go when I finish. I'm gonna let y'all go. I know y'all got stuff to do, but I do too. This is my class time, and we're gonna get the test on Wednesday, no matter what. Okay. So I wanna
on
make
Monday
sure
we
we're all
have
good.
review, right? Monday we have review.
Now we still got to go over chapter 5.
It's still?
Yes. Yes.
Oh, that's fine.
You good, Mom?
Silas,
Okay.
pages.
Ugh.
Oh, chapter 5, yeah.
All right.
So you're gonna finish the Davis chapter?
Yes, sir. Yes, ma'am. Yes, ma'am. I sure am. The maximum value for duty factor is going to be between 1 or less or 100%. And 100% that would be continuous wave transducer, correct? What if my transducer is always listening? What would my duty factor be? 0. 0 because it's never transmitting. Because it's never transmitting. Not trying to ask you a trick question, but that's just logical. That's just the truth. Okay? It's only achieved with a continuous wave transducers. Imaging systems, meaning what we use in the lab, in the clinic, must always be less